The first thing you always want to do when programming with CAM in Fusion 360 is creating a setup. This is where we tell the software how things are located on our CNC machine, such as what we're machining, XYZ direction, location, and stock. Creating the setup is straightforward with Fusion 360. Let's take a quick look. We will change the workspace on the ribbon bar to CAM and then select Setup. Starting from the top of the Setup menu, you can select the operation type. Notice how Fusion 360 automatically provides a flyout window with helpful descriptions. This is clearly a milling operation, so the default option will work here. If this was just a single part file, I would not have to do the next step. But since this is an assembly, I will specify which one is the part model I am going to machine. This will be helpful if using automatic toolpath selections and when simulating the toolpaths later. I will select the Model button and then click anywhere on the model I will be machining. Next, I will concentrate on the XYZ axis and the work coordinate system. The work coordinate system is also by many referred as G54, G55, and is where your part 0 is located. Out on the machine, your XYZ axes are pretty defined, but on a CAD model there's no set rule. Many times when you receive a model, an axis will be flipped in the wrong direction. Notice the triad or 3D gnomon display on the model to show axis direction. This is easy to adjust in Fusion 360. When selecting on the model orientation, you will see many great options to control the XYZ. My personal favorite is Select Z and X-axis. By selecting the top face of my model, the triad will change the Z direction. And also notice that there is a Flip Z-axis checkbox in the Property Manager. In this example, my X-axis is where I want it, but just as easily as adjusting the Z-axis, you can click the X-axis button and any edge selected on the model will control that axis. You have a few different choices to select the work coordinate system. The model's origin, an intersection point on the model, and then either model box point or as I pick here, the stock box point. This will take into consideration the actual measurement of your stock that normally is a little bigger than your finished model. You can control your stock sizes on the second tab. Fixed size box is the measured dimensions of the raw stock. Relative size box lets you add extra stock on each size of your CAD model. Also be aware that you can use from solid. This is a great option if you have a CAD model from before or after another operation, such as heat treat or a coating operation. And it's also great if you're dealing with castings. In my case, I'm going to machine this out of a raw block of steel, so I'll leave it at fixed size stock. All I have to do now is hitting OK, and our CAD model is aligned with what we have out on the machine, and we are ready to apply the first toolpath.